Hello students, welcome to the class on gravitation. Okay, this class is made for 9th standard students. I'm covering chapter 9 uh, of CBSE science book and chapter 10 of Karnataka State Syllabus science book. Uh, in the previous classes, right, we learned about gravity, acceleration due to gravity, the free fall, a couple of other stuff. Before we jump into more advanced topics like weight, thrust, the conditions for floating, etc., 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 I thought of giving you some picture why we need to understand gravity. What is the relevance of this topic? Okay, let's imagine in the beginning. Okay, we don't know what happened in the beginning. Let's assume for a moment someone created this world or Big Bang happened. Okay, so then world got created, right? So with this world, so who knows? Maybe multiverses could have been created. We don't know that, right? So I'm putting them blank here. So world. So world can broadly classified into physical world and metaphysical world, right? In the metaphysical world, we talk about very abstract concepts like thoughts, the mind, consciousness, other spiritual, words or jargons. Let's not go in that direction. Let's talk about physical world where we really touch, feel, and see, and everything, right? So this physical world is made up of matter and energy. We know it very much clear, right? So what is matter? So matter can further be classified into solids, liquids, gases, and plasma. There are four shades of matter. We know that, right? So at the same time, energy also. See, there are so many ways to classify the energy. I'm classifying it like this: potential energy, kinetic energy, thermal energy, nuclear energy. There are a couple of the energies which we can't fit them here, but that's not a goal. Classification of energy is not a goal here. Okay, let's come back to the force here. Look at the force here. So when Big Bang happened, the forces also got created. Okay, so it's not about creation. So we say forces is something which they interact with matter and energy. Okay, so in the at the singularity at the Big Bang, matter and energy were like single dot. They were like coexist together in a singular position. The moment what is Big Bang? Big Bang is moving from singularity to the duality of it, right? Think of Advaita uncovered, right? Not go there. Like in Shiva Shakti, so many concepts comes here. Shiva is matter, energy is Shakti, all that comes into picture. But then what is force? Force is a fundamental force, we call it as. We got four fundamental forces. In the Big Bang, they were like a unified force, which they called as super force. Over in the few seconds itself, microseconds or nanoseconds or early time itself. So the force got again further. Well, gravity is the first one to get separated. So we get to see four kinds of fundamental forces: gravity, electromagnetism, strong nuclear force, and weak nuclear forces. Okay. Now our focus, what is the force? Force interacts with matter, force interacts with energy. Now it's our time. Science is what? Science is a way to understand. It's a methodology to understand the world. Basically, the creation. One of the goal is of the science, right? So the how we need to understand how force interacts with matter and energy, but we cannot you cannot take up all forces together at the same time and understand, right? Let's take up in this session how gravity interacts with matter. Okay, and of course the goal of this class is not how gravity interacts with energy, right? Remember, gravity interacts with matter. That's the goal, right? Not how we are going to learn the topics. Okay, now let's come back to the syllabus. Okay. So, as I mentioned in the beginning itself, it has got six topics: gravitation, free fall, mass, weight, thrust and pressure, and Archimedes principles. In the previous two sessions, we learned gravitation and free fall. In this session, let's focus on mass and weight. Let's start with mass. Before starting with mass, as I explained in the beginning, we should uh, also try to understand what is matter. Okay, I told it clearly, right? The world is made up, the physical world is made up of matter and energy. Then what is matter, right? And how it is connected to mass? Let's see it. So, what is matter? Matter is anything. See the word anything, it can be any stuff, right? Matter is anything that takes up space and has mass. It can be solid, it can be liquid, it can be gas, it can be plasma, it can be rock, it can be powder, salt. You imagine whatever. Okay, whatever it takes up space, whatever it takes, has a mass. That's a matter. So now everything from tiny ant to a giant star is a matter. Okay, imagine this. Right. So now, what is matter again? Matter is the stuff of the universe. Stuff can be anything. I said it's the stuff of the universe. Right. So mass is what? Then come back to the mass. Right. Mass is a measure of how much matter an object has. Okay. How do you understand this? Just imagine something like this. Okay. Imagine two bags. Empty bags. Okay. So what is done is it no, imagine that whatever you feel it inside the bag is a matter, a stuff. It can be books, it could be whatever, right? So now take one bag, okay, and take other bag. In the first bag you put you place two books. In the second bag you place 10 books. Now look at it. Assume for a moment that books matter means the books. Okay, the first bag has less mass because it has got only two books. The right one has more mass because it got 10 books. I'm talking about relative words. Okay, that's how we can say that mass is a measure of how much matter an object has. Okay, I think now it's very clear what is the difference between mass and the matter. Matter can be anything. We don't talk about the measurement there in the matter. It can be anything. Okay, but mass is a measure of how much matter is in a given object. Okay, now coming back, how to quantify the mass? We know it, right? So we have to see mass is about quantification. The quantifying in the matter, right? So mass is usually measured in kg, kilograms, or grams. Of course, kg is a SI unit. Okay. Now what is now I told you in the beginning, right? Just a few minutes back. So what are we going to do? We are going to learn how gravity interacts with the objects, matter, right? So what is matter? Matter, mass, all are related words. Now how this motion? Of course, motion is caused by one of the reason for the motion to cause is the force. Gravity is one of the force, right? So that's how we are connecting now. Okay, how mass and motion are related. Okay, more mass an object has, more force takes it to move. If an object has a more mass, you need to use a more force to move or to change its speed or to change its direction. If object has lesser mass, you would relatively need a lesser force to move that object or change the direction of the object or change the speed of the object. Correct? So it means mass and force required to make it move are related. Okay, mass of an object is a measure of its inertia. Okay, what is inertia? We'll cover it in detail in a separate video. Let's not go there. But greater the mass, greater is the inertia. Okay, I think they are related, right? Now let's understand what is mass and weight related, how they are related. Okay, mass is different from weight. Remember, we always say this guy weighs 10 kgs at 60 kgs or 100 kgs, right? Something, right? So now this is something very very things, one of the very important thing to be taken care. Mass is not same as weight. Mass is different from weight. So what is mass? What is mass? He said that measure of matter, right? What is weight then? So it is a force of gravity acting on an object. It means weight is a kind of a force. What kind of a force? It's a force of gravity. What this gravity is acting on a matter. Remember, I told you in the beginning, right? This forces interacts with matter. It means in this case, gravity is acting on object. What is object? Is a matter, right? It's made of matter like that, right? So now mass remains same. Mass will not change. You take an object with a given mass. What is it? This mass will not change. It will remain same. Either take it to the earth, take it to the moon, take it to outside the space. Mass remains same, but okay, the weight will change. Okay, but weight will change depending on gravity strength. Okay, for example, earth has a different gravity, moon has a different gravity, maybe some other planet would have maybe having a different gravity, right? So if you take an object of a given mass and weight will be different in different places, planets, because it depends on gravity strength. Okay, Till now, we started with matter, then we moved to the mass, then we said weight is different, right? Let's start. Understand what is weight now? Okay. Okay, let's recall what we learned in previous sessions, right? See, we know Earth attracts every object with a certain force. We know it, right? Earth attracts every object with a certain force. We learned it in previous class session, right? So now this force depends on the mass. Remember, the force the which Earth attracts, right? Any object, right? The force depends on mass of the object that it is attracting and acceleration due to gravity, which is constant for a given planet. Remember, okay? All right. So now, then it is spherical. Remember, okay? So the weight of an object is the force. What is the? Let's define what is weight, right? Weight of an object is the force with which it is attracted towards the earth. It's a definition to remember. What is weight? Weight of an object is the force. Weight and force are similar, concepts. Remember, weight is similar in concept compared to the force. Weight of an object is the force with which it is attracted towards the earth. Okay, remember, an object is attracted with some force. It means the weight is that much. Okay, okay. Let's derive that, or let's understand with formulas. We know that F is equal to ma. What is this? See, Newton's give us three fundamental laws of motion, remember, right? In that, second law is this one. The force is directly proportional to mass of an object and of course acceleration, right? F is equal to ma. Newton's second law. Okay, so that is now we see that the acceleration of the body. Now see that the body is getting accelerated, right? Because it is falling towards the earth, right? Now it is equal to acceleration due to gravity of it is at the earth's acceleration due to gravity, right? You see g. Now I can simply, now it's a constant, right? This acceleration is caused because of the earth's gravity. So now we are specific. Now acceleration is happening because of gravity. I'll replace a with g, of course, which is a constant, 9.8 meter per second square. Okay, now again back to the definition. I'm just repeating it. The force of attraction of the earth on an object is known as the weight of the object. See, how do you define weight? It's a force of attraction of the earth on an object. Okay, similarly, okay. Now, how? See, now I have to differentiate now. See, force is a very generic term, right? So I want to be very specific now, because this is a force we are talking about with respect to the Earth's attraction, right? Let me use a different, the terminology here. Let me call it as a W, weight. Okay, so it is denoted by W, which is called weight. Weight is what? Weight is again a force, remember, but this is a force of attraction of the Earth on a given object. Okay, now substituting now equation 914. Okay, now what is that? See, I replace F with W, that's all. Of course, W is equal to m into g. This is what? Weight is equal to mass into gravity. Okay, the SI unit of weight is same as of the force. Remember, see, I told you, right? What is force? Force. SI unit is newtons, right? Now I replaced this. Weight is a specific case of a force. It means force of, what is a specific case? It's a force of attraction of the earth. Okay, so I'm very specific, but unit remains same because both of them are forces, right? So a SI unit of weight is not the kg. Remember, generally what is your weight? Oh, we say 60 70 kgs or 55 kg, 65 kg, right? Now so remember it, the SI unit of weight is not the kgs. SI unit of weight is newtons. Okay, the weight is a force acting vertically downwards. Okay, remember what is for weight? Weight is, of course, it's acting downwards because Earth is attracting, not repelling. Okay, weight is a force acting downwards, vertically downwards. So remember one more thing. It has both magnitude and direction. Okay, its direction is towards Earth. Okay, it has direction, and of course it has a magnitude. Say it's 60 kg, or say 70 kg, or say 60, like that. Okay. Yeah, this is done. Let's go with I think we already pretty much know what is matter, what is mass, and what is weight. Let's slightly try to differentiate, again, just to recall, re you know uh, uh, reinforce the learning. Okay, so what is gravity? Gravity, g, what is this gravity? See, I'm just acceleration due to gravity. Sometimes we call it as just gravity. Okay, basically what we are talking is g, acceleration due to gravity, is constant at a specific location. Okay, Okay, see, if you think we derived this in our previous classes, right? What is G? Acceleration due to gravity, or simply we call it as gravity. Gravity is equal to G into m by r square. What is it? What is G? G is a universal gravitational constant, which is some number, right? And what is m? Because in this case we are talking about Earth's, the gravity. It could be mass of Earth, okay? And in this case it's a radius, right? So it's the radius of the Earth, okay? Now G is equal to capital G into m by r square. See, G is constant, m is constant, mass of Earth is constant, radius, assume Earth is very spherical, assume it's spherical, but it's not perfect spherical. For all the reasons you can assume it's spherical, and r is also we can take it as constant. So G, a gravity, we say it's a constant. We take a number which is 9.81 meter per second square, right? Now we know that gravity is constant at a given specific location. Now let's go for what is object weight. Okay, what is object weight? Weight is directly proportional to its mass. We see F is equal to ma. So F I replace it W, weight. So force is ma, mass into acceleration. Right? In this weight is equal to m into g. See, directly proportional to the mass. Okay, so W is equal to m into g. Of course, which is derived from F is equal to m into a. Okay, now weight and object can be used. See, look at this equation. What is this equation? Right? This equation, this is constant, right? So I can, if it is constant, it's always constant. Okay. Now, if I more the mass, more the weight, right? So more the mass, more the weight. Less of the mass, less of the weight. As simple as that, right? Weight of an object can be used as a measure of its mass. Okay, because gravity is constant. So more the mass, more the weight. Okay, mass stays constant. Remember, mass stays constant everywhere. Okay, you take an object to the Earth, to the Moon, to some other planet, say Mars or Jupiter, whatever. Mass remains same for a given object. Okay, but weight changes. The weight of an object is not same in both Earth and the Moon. Remember, weight changes. Why it changes? Because G is different for this G is different for Earth and different for Moon. So remember what is summary here? Mass is same you irrespective of the places of a given object. Okay, but weight changes from place to place. If and different places may have a different gravity. That's the reason, right? Okay, let's understand force. Okay, what will be the force exerted by Moon on the object? The force exerted by Moon on Earth on the object is the same or not? You'll see understand it, right? In this. Okay. So we learned, right? In the past we learned, right? What is weight? Weight is nothing but a force. So weight is a force, a specific case of a force. Remember, the weight of an object on the Earth is the force with which Earth attracts the object. Similarly, we can say the weight of an object on the moon, that means weight on the moon, okay, is the force with which moon attracts the same object. Okay, right. So let's see, these forces are same. The force of attraction of the Earth, the force of attraction of the moon on a given object is same or not. Let's understand that part. Okay. What is mass? The mass of the moon is less than that of Earth, correct? So of course, I just captured them here, right? This is table taken from your book. So the mass of the moon is less than that of the Earth. By 81 times, remember. So Earth has 81 times more mass than the moon. So this is the exact number I gave, right? If you take the ratio of it, you will get it 81 times ratio. Okay. Then what? So what? What happens? Okay, Earth has a more mass. So what? Question, right? So look at the formula of the universal law of gravitation. So universal law of attraction. Right? So universal law of attraction or gravitation. I mean, attraction is the right word, right? So what is this word? F is given by Newton. Remember this formula. Force is directly proportional is equal to G into m into d square. Where m small m is the mass of the object. Of course, the same object I'm using in both the places, Earth and the Moon, and of course it's constant; it will not change. So I'll ignore it. So G is the universal, constant, universal, gravitational constant. I ignore it. Now, what is this? Mass and D. When you're calculating the weight, generally we go for the radius of that as the distance between two objects, right? So now, what is this happening? Since we proved that, so Earth has a more mass, Okay, Earth has a more mass, so naturally the force of the Earth will be more, right? So it means due to this reason, okay, and of course because mass of the Earth is less here compared to the, so mass of the moon is less here compared to the Earth. I say force exerted by the moon will be less. Okay, so due to this reason, moon exerts lesser force of attraction on object. So what? Okay, let's understand. Let's continuation of the previous slide, right? What is that we learned? The moon exerts lesser force of attraction on a given object compared to the Earth, right? Let's see how it boils down to how it's get reflected as a weight, okay, different weight. So in the book, it's the table is given where it goes mass of the Earth, mass of the moon, and radius of the Earth and radius of the moon. Okay. Okay, so let's take some terminologies, okay, and compare the weights in both on both sun and the sorry, not sun, the moon and the earth, right? Terminologies and values. Okay, one, let the mass of the object be m. Correct. Assume some football or say some object, some bag or a book or whatever, some person maybe. Assume the mass of the object be m. We know, right? The mass of an object will not change. It remains constant even if you take it to different places, to the Earth, and the Moon, or some other planet. So m remains constant of a given object, right? Let the mass of an object be m, right? So now let's weight of the moon be let the weight of the object on the moon be Wm. See the same generally we we use W for a weight. So let me add a uh, m to it, suffix, and say Wm. So weight of an object on the moon is Wm, right? So similarly, weight of an object on the Earth is We. E stands for Earth, M stands for Moon. W Earth or W Moon. Let the mass of the Moon be mm. So generally we use for m, right? M mass of the Moon, mass of the Earth. Similarly, okay. So let the mass of the Earth be me, right? So yeah. Similarly, we talk about radius also, right? So let the radius of the moon be Rm, radius of the moon. Let the radius of the earth be Re, radius of the earth. E stands for earth, M for moon. Let's go. Right, great. Okay. Now we know universal law of gravitation, right? Given by Newton's. What is that? What is the universal law of gravitation? F is equal to force is equal to G into M by R square, where G is a universal the gravitational constant. R is radius. Maybe in case of R, it's a radius of an object of the attracting body like moon or earth. Okay, this is mass of the attracting body. Okay, either moon or earth, depending on two cases. M is of course the object which is getting attracted either on moon or earth. Hmm? Now, so what is that by definition? What is this definition? What is the definition of earth? Oh, sorry, what is the definition of weight? Weight. The weight of an object on the earth is the force with which earth attracts, correct? The weight of an object on the earth is the force with which earth attracts. Similarly, the weight of the object on the moon is the force with which moon attracts the object. Okay, let me put it in formulas. Okay, weight of an object is equal to W into M into G, right? So W into M into G. So now why I use W? Because I replaced force with weight. Because weight and force are same, I can change replace force with weight because it's a specific type of force. Weight is a specific type of force. Okay. So W is equal to M into G, where G is a acceleration due to gravity, which is constant for an Earth or a given or moon. Also, it's different number but constant, right? M is mass of an object, right? So now acceleration due to gravity, we know it, right? What is this G? I'm just trying to get this formula. Okay. What is G? G is equal to capital G into M by R square. We already seen it. Okay. Let's not go. Now, then what is this? Then let's calculate what is the weight of the moon, weight of the object on the moon, and of course weight of the object on the earth. Okay, let's go with moon on the moon. Okay, the weight of the object on the moon is equal to n what? So I just use this formula here. That's all. Right? I replaced Wm. Okay, I replace force with weight now. Wm, weight of the moon is is equal to g. Of course, it is constant. I don't want to add any suffix there. G into mm. I replace m is mass of the moon into object mass will not change, so I'll be keeping it as it is. And radius, of course, radius is different for moon and earth, so I'm using rm here for a moon here, right? So now what is this? Let's go there. The weight of the object on the earth, again I'll use the same with some modified the terminologies. All right. Right. So what is this? Weight of the object on the earth. Remember, weight of the object on the earth is equal to g into me, mass of the earth, into m by re square. Right. Let's divide one by another. Okay. Dividing equation 5. This is equation 5 and this is equation 4. Or dividing what? Right. Dividing equation 5 by 6. It means divide this equation. Right. Okay. Right. So W of course it should be 4. Remember. Okay. This is 4. 4. Okay. So now what is this? We by Wm is equal to, see, G gets cancelled. I don't bother. M, mass of the object, I'm using the same object in both the places and the mass will not change. They get cancelled. So I'll write this We by Wm. We by Wm is equal to Me by mm. Okay. And remember it goes up. Okay. So now Re and Rm. Correct? Hmm. Okay, I think you should be able to make sense of this equation, right? So me by mm, okay, divided by rm, because it denominator by re, right, whole square. I mean, like rm by re whole square also you can write it. Now let's understand. See, we have got two ratios, right? Ratio of the masses, ratio of the radiuses, right? Let's understand what is the ratio. Okay, look at this. I see this is taken from the table itself. So if I take 5.98 in 10 to the power, see 10 to the power 24 it is, okay. 7.3 in 10 to the power 22 here, remember. That is equal to 598 divided by 7.3. It is equal to approximately 81. So now what is this ratio? This ratio is 81. Okay. And let's understand what is Re by Rm ratio also. So similarly, I need a ratio of this Re by Rm. Okay. See, Me by mm, Re by Rm. What is this? What is Re? Radius of earth, it is 6.37 into 10 to the power 6. 6.37 into, see, this is 6 10 to the power 6. 1.74 into 10 to the power 6, remember, just a small mistake. Okay, that is equal to 6.37 by 1.74. It is approximately equal to 3.67. Okay, this is approximately equal to 3.67. 667 or 67, you can say that. Right, look at the ratio. Mass ratio of the mass also high. I mean, earth has more mass. Ratio of the radius is also high. Of course, earth has a bigger radius, and ratios are given here. Then let's substitute them here, right? Okay, and of course let's take, because we need square terms here, let me take square term. 3.67 square is equal to 13.4, right? Right. So now if I take, because I need to reverse, right, or rm by re, I'll take 1 by 13.4. That's just a typical mathematical manipulations. Okay, so now right. Okay, so now what is it? What is this? We by m, weight on the earth divided by weight on the moon, is equal to 81.25 divided by 13.4. 1 by 13.4 or 13.4, right? So it is equal to 80, approximately 81 by 13.4, approximately it is 6. We're not bothered about the exact number here. So this ratio, weight on the earth divided by weight on the moon, is equal to 6, right? So earth is in the numerator, remember. So earth is in the numerator. Weight 6 by 1, I can write it. Okay, weight on the earth is being numerator. Okay, weight. Now, you see, this is what exact summary, not that, right? Weight of an object on the moon divided by weight of the object on the earth. I just reversed it. So take the reciprocal of it, is equal to We. No, this should be Wm. Okay, and this should be We. Wm by We is equal to 1 by 6. Clear, right? Now that's all. Okay, it means for a given object, the weight on the moon means the weight on the moon is equal to 1 by 6 of the weight of the earth. Or if I want to calculate weight on the moon, just measure the weight on the earth and just divide by 6. Okay, weight on the moon is equal to 1 by 6 times the weight on the earth. Now let's understand our same concept is solving some problems, right? So now first let's take this example. Well, a mass of an object is say assume 10 kg. Remember, mass is given and unit is kg. Okay, they're asking you to find the weight. Remember, what is the weight? You should be careful here, right? What is given? Mass of an object. What you need to find? Weight. And where weight? Remember, weight changes from place to place. You need to find the weight on the earth. Hmm. As usual, we start with solutions. Solution, of course, and of course, in the solution, we start with what is data given, then what is the formula used, what is the calculations, and not then answers. Okay, let's understand what is given here. Okay, and data are given. Okay, what is given? Okay, what is given? Mass m is 10 kg. Mass is given, and of sometimes we have to assume something, right? For example, g, they expect you to know that g is constant and at it. Okay, what is acceleration due to gravity? It is constant, and you take it as 9.8 meter per second square. See, it's not given here, but some of the terms you have to buy it and remember it. G is equal to 9.8 meter per second square. Right. Now, what is formula? So, what is the formula? We need to use the weight of the object. The weight of the object on the earth is the force with which earth attracts. Right? Force with what is the force formula? F equal ma. So, now I'll replace it. W is equal to m into g. Correct. Force with which earth attracts. Right. So, now what is this formula? This is the formula. F is equal to m into g. Right. Now we know we got the formula. Just substitute them, calculation substitution, right? What is the mass of the earth is given 10 kg, right? And of course, what is this gravity? Gravity is given 9.8 meter per second square, right? Substitute. What is this? 9.8. I mean 98. Weight is equal to what? 98. So what is weight? What is the unit of weight? Not kgs. Remember the weight. SI unit of weight is 98 newtons. All right. So answer is weight of the object is 98 newtons. Be careful about the unit. I'm just stressing again and again, right? Uh, Now let's go for other problem, other example. Okay, an object weighs 10 newtons. Okay, again same as mass is equal to 10 newtons. When measured on the surface of the earth, okay, on the earth its weight is 10 newtons. What will be its weight when measured on the surface of the moon? We know the formula, right? 1/6 times. Let's see that. As usual, we start with a given and then formula, then calculations, and then answer. Okay, given is missing. Just think of it. Data. Let's what is data or given? Okay, what is given? So mass is equal to weight on Earth is 10 newtons. See what it weighs 10 newtons, right? Weight on Earth, E stands for Earth is 10 newtons. And what you need to find? Weight on Moon is equal to what? Measure what is the weight on the Moon? Okay, let's do that. Okay, what is the the formula, right? Weight of the object on the moon or weight on the moon is equal to 1/6 times of weight on the earth. So now, right, we can write it Wm by W. Weight on the moon by weight on the earth is equal to 1/6. Let's substitute them. So what is weight of the moon? I need to calculate. Weight of the earth is 10. 10 is given. Okay, into 1/6. What is Wm? Cross multiplying. Okay, 10 by 6. 1 point. Answer is 1.667. What is the unit? Be careful. We are calculating the weight. The unit is not kg, but newtons. Okay, the weight on the object on the surface of the moon is 1.67 newtons approximately. See that? Okay, then let's go. Now for questions. What are the questions? What are the differences between mass of an object and the weight? And I think I already explained you, but let's practice again. Okay, what are the differences between mass of the object and its weight? Then why is the weight of the object on the moon? I already explained it. You and I with formulas I explained, right? Why we can do it? Okay, in different way. Why is the weight of the object on the moon? Okay, is 1/6 the its weight on the earth, right? Okay, let's take the first one now. What are the differences? Let's go one by one between mass and weight. Okay, left side is mass, right side is weight. Okay, so what is, I told you already, right? What is mass? Mass is the amount of matter in a body. It's a stuff. Mass is what? Sorry, matter is what? Matter is stuff. Matter can be anything. Okay, so here what is mass? It's a measure of matter, right? It's a measure of stuff, right? Now we can say the amount of matter. in a given body. That's a mass. If it has got a more matter, it will get more mass. It's a measure or it's the amount of matter in a body. What is weight? Weight is nothing but a force, remember. It's a force of gravity acting on a body. Weight is nothing but it's a force of gravity acting on a body. Alright? Then what is mass? Mass is a measure of inertia of the body. It means more the mass, more the inertia body will have. It's a measure of inertia. Okay, what is weight? Weight is measure of gravity. It means more the gravity, more the weight. Okay, of course, it here mass is independent. It is not okay. I mean, for a given mass, remember. Okay, it's a measure of gravity. Okay, then the mass is a scalar. It has only got magnitude, say 10 kg, 20 kg. It doesn't have a direction. Okay, mass is a scalar magnitude. A scalar mass is a scalar quantity and it has got only magnitude. Whereas weight is a vector quantity. It has got a magnitude and it has got a direction. See, weight is down, force is downwards. Okay, remember. Okay, measured in kilograms. SI unit of mass is kg. Okay, sometimes we also talk about use grams. Okay, right. So now what is measured in newtons? The weight is measured in newtons. Remember, right? The SI unit is of course newton. Right? Its mass is constant. You take the object anywhere. You take an object anywhere, Earth, Moon, other planets. The mass is constant. It remains same. Whereas weight change varies depending on the location and gravity. Assume Earth, we give a same object as a different weight on Earth and different weight on the Moon and different weight on Mars and like that. Because why? Because the gravity changes. On the Earth itself, maybe weight could be different because Earth may slightly experience different gravities in poles and equatorial region. Otherwise, for all the reasons, weight varies depending on location and gravity. Okay, and it's of course it's denoted by m and it's denoted by w. Okay, though it's a force, we use specific word weight. Okay, so it is what? How do you calculate mass? Mass is nothing but volume into density. Okay, we'll talk about it later. Otherwise, simply mass is nothing but volume into density. How it is? Well, mass weight is calculated using mass into acceleration due to gravity, mg. Okay, so these are the different some of the differences between the the mass and the object. See, better you buy them or understand them, because these kind of questions appear in the exams. Let's do next exercise, next question. Okay, what is the question now? Why is the weight of an object? Why is the weight of an object on the moon is 1/6? That means less than or 1/6 the weight on the Earth. Assume the weight on the Earth is 6 kg. The weight on the moon will be 1 kg. 1/6. Why? Okay, let's understand. Right, this is a question we need to answer it. I'm trying to answer in two ways. You could pick any one, right? So the weight of an object on the moon is 1/6 its weight on the Earth because moon has less mass and less gravity. What is the first answer? Moon has less mass compared to Earth. Remember, moon has less gravity compared to Earth. Remember, moon has less mass, moon has less gravity. So weight of an object on the moon is less. Okay, how to understand in formulas? What is the formula for weight? W is equal to m into g. Okay, now where w is weight, m is mass of the object, and g is the acceleration due to gravity, maybe of Earth, maybe on moon, depending on the cases. Right, now this is important. What is mass? The mass of an object is constant, correct? The mass changes. If I take an object, I told you many times, repeating again and again, mass of an object will be constant. It will not change even if you take an object to different places, right? Mass of an object is constant, but the gravity varies depending on the location. Gravity varies depending on the location, right? Gravity varies depending on location. Remember. Hmm? So the gravity on the moon is how much? 1.62 meter per second square. What is the gravity on the moon? 1.62 meter per second square. Whereas gravity on the earth is, means acceleration due to gravity on the earth is 9.81 meter per second square. Okay, now look at it. Mass remains same, but body it's seeing the same object is seeing different, the gravities, naturally weight should be different. Okay, therefore the weight on the moon is what? Replace this equation. Okay, weight on the moon is equal to what? Mass remains same. I'm using as it is into g. G on the gravity on the moon is 1.62 meter per second square. So 1.62 m. So weight on the earth is similarly that weight on the earth is m into g, m into 9.81. Okay, this one, right? Now you divide them, this by this, W1 by W earth. Okay, equation 2 by equation 1. Okay, let W earth be on the numerator just to get a decimal number. Okay, I mean bigger number, right? W earth on W moon is equal to 9.81 divided by 1.62. That is approximately equal to 6. What is the meaning? What is the takeaway? So it means if you take it in cross multiplication, W on the moon is equal to W earth by 6. Or 1 by 6 times W earth, right? So this means that the weight on the moon is, if you take it as 16.5, 1 by 6 is equal to 0.165, it means 16.5%. Okay, the weight on the moon is 16.5% of the weight of the earth, or 1/6 of the weight of the earth. As simple as that. This is what we're talking about, 1/6, because weight of the moon is left side. Okay, this is one way to understand it, right? I mean, let's okay, one way to understand this, right? One way to have it, like weight on the moon is lesser than weight on the earth of a given object. So how did we solve it? By taking gravity, acceleration due to gravity on the two bodies, earth and the moon. We took different values of gravity, 1.62 meter per second square for moon, 9.81 for earth, and we calculate the weight on the moon, weight on the earth, and we see that the ratios are 1 by 6. One way to prove it. We did it. Now let's do it other way. Okay, using universal law of gravitation. Okay, this is using weight formula. This is using universal law of gravitation. This one, right? Before using universal law of gravitation, let's understand what is the ratio of radii of earth and moon. It means radii of earth and moon. So r earth by r moon, radius of earth moon. What is the ratio? It is 3.67. 3.67. Okay, remember. Okay, so now what is the ratio of masses? Masses means what? Mass of the earth by mass of the moon is equal to how much? 81. Okay, correct. Now, so what is, okay, now come use the word universal law of gravitation. F is equal to what? F is equal to g into m by r square, right? Now substitute them. We have two formula: weight on earth, weight on, sorry, the force on earth, force on moon. We can use two formulas and calculate it, right? So now if you subtract them, you weight divide weight on earth by weight on moon is equal to gg cancels because it's a universal constant. Okay, the mass of the earth remains same because mass of the object remains same because because that's a property. So but only things which are different are mass of the earth and mass of the moon. They don't cancel because there is a ratio involved, and radius of the earth and radius of the moon whole square, right? Now we do the calculation for mass of the earth, mass of the moon ratio, right? What is this? 81. Mass of the, radius of the earth, radius of the moon, what is the ratio? 3.67, right? Substitute them. So 81 by right, what is this? Okay, what is this? 81 by 3.67 square, right? So that is equal to, if you calculate, it will be somewhere around 6. See, the both ways, both are the same. What is the learning? What is the learning? It means the weight on the moon, the weight on the earth is 6 times the weight on the moon. The other way to put it, the weight on the moon is 1 by 6 times the weight on the earth. If you talk about percentage, the weight on, say, object on the moon is 16.5% of the weight of the same object on the earth. Okay, just to calculate the example, for example, if you weigh, assume your weight is 60 kg on the earth, if you go to moon and your weight will be 60 divided by 10, 60 divided by 6, 1/6 of 60, 60 divided by 6, 10 kgs. This is a takeaway, right? Now what is, let's see where are we in our classes, right? So now till now we learned as a topic 3 learned mass and uh, see and topic 4 weight, right? Both are completed now. In the next class, let's talk about thrust, thrust and pressure. Okay, why we need to study gravity? Maybe I'll make a separate video for it. Okay, thank you very much for your time.